Introduce our speaker, Joaquim Neto. Joaquim is a senior solutions architect here at Verato with decades of architecture experience in information management, with a particular expertise in healthcare with master patient index and health information exchange technologies. Before joining Verato, Joaquim worked at Initiate Systems for many years. And one more thing I wanted to point out is that we were recently named to the Gartner Cool Vendor list in data integration and data quality. So that's exciting for us. With that, I will go ahead and hand over to Joaquim, and we can get started.
All right, thanks, Rachel. And thanks, everyone, for joining us today. We're going to have a just short webinar here about Verato's solution to patient matching. We'll start off with just a very brief background on where this problem fits into the healthcare marketplace and why it's such a big deal right now. Then we'll talk a little bit about some of the challenges that people are facing. There's been a lot of organizations put a lot of research into this lately, so we'll talk a little bit about that. And then we'll get into some specific solutions that Verato provides to help you deal with this problem of integrating patient data across multiple organizations and multiple sites. And finish up with some brief things about how you can get started and engage with us. So a little background and context, which all the folks on the call today, just looking at where you're all from, are intimately familiar with the business drivers today. So I don't need to preach to the choir, but what we're seeing is we're seeing that the major trends in the industry today are all requiring more and more integration of data across systems. So whether it's ACO initiatives, trying to integrate data to understand populations better, to manage risk, to deliver better care to chronic patients, chronic disease patients, whether it's trying to integrate and engage directly with the consumer and integrate with applications that consumers are starting to use. All of these trends are requiring more and more data to be integrated across more and more systems. And the common thread that we see and where we come into play for that is that as you add these additional systems to your landscape, you've got to figure out which records and which systems belong to the same patient. And so a big part of this problem of interoperability across these systems comes down to figuring out who's who, whose record is who, and matching the patient data accordingly. So seems like a simple problem. When you look at the landscape of the different types of organizations in healthcare today that, as I mentioned, are increasingly collaborating more and more with each other, within the same types of organizations and then increasingly across different types of organizations. This idea of being able to exchange clinical information or other information about a patient in the course of care delivery or analytics seems fairly simple. One organization connects with another, asks if they have information for the same patients that they're looking at. That organization looks up the patient record in their own system and can reply back with the relevant information that patient. So seems like a simple process. I'm sure everyone on this call already knows it's not quite that easy. One of the things that makes it increasingly complex is as we are moving to this environment with more and more collaboration, is if you're just two organizations or two systems that are trying to integrate around a single view of a patient, there's a certain degree of problem. But as you expand out your network and are integrated with more and more participants, the problem gets very complex. And this is sort of meant to be a shocking diagram, but it actually does reflect reality in a lot of cases, where the problem of figuring out who's who, which records match to the same person, is often federated to these different places. Each organization has different capabilities in terms of technology. They have different business processes and business rules. All of these things amount to creating this big challenge we have today. There's been some interesting things happening in the last year or so with Ahimo making some recommendations on standardization for matching criteria. The Intermountain and the Project Sequoia group did some interesting studies on what standardization of data and the matching rules can do to help solve this problem when you have all these different participants trying to independently determine which records represent the same person. So there have been some interesting things out there and research into that. And we're going to, as we go through today, talk to you about some other approaches that we have to address the same problem. So again, the idea is simple, and if you've got two records about the same person, well, if all the data that you had on both of those systems was the same, then it's not a hard problem to solve. You know that John Smith in the acute EMR on the left is the same as the John Smith in the ambulatory EMR on the right. You know, no problem, everyone goes about their business. Unfortunately, the reality is that when you're trying to match records across systems, the data just doesn't often line up that nicely. Most of the times it doesn't. And that's because people in real life have events that change the data that identifies them. So people move all the time. You know, 15% of the people move every year. You change your phone number. Their gender changes these days. That's not even counting the types of data entry errors that HIM professionals have been familiar with for years and trying to overcome. So the reality is, in the end, the data across these systems that you're trying to use to match records just isn't good enough for the technologies today to be able to get results, the correct results, as often as it should. So again, stats that HIM and other data professionals are certainly familiar with. You know, 30+% of the data that we see in medical record systems have some type of problem in it. There's studies out there that verify this, and we've seen this in our work with clients, that in addition to these sort of natural errors of address changes, name changes, things like that, you have all the typical more data quality, data entry type errors. And these things add up to make it difficult to get the right answer when you're trying to create this single view of a person that's so important to healthcare initiatives today. So how does this usually work? The way the sort of state-of-the-art technologies work today, you're looking at 4 systems on the left, and each of them has a representation of data about a given patient. And what people try to do with existing EMPIs and other data quality and ETL solutions is you take a record from each system and you compare them to each other. And little balls on this diagram each represent a different attribute. So, you know, name, address, and phone number. And if those line up with each other, each record has a name, has an address, has a date of birth, say those 3 attributes, and they're the same, then it's the same person. You know, you've accomplished your linking of the records. You can now share data, or you can aggregate clinical and financial information up to that person's true identity. Knowing that there's errors in systems, the sort of next stage of evolution in patient matching was to account for those small data errors. So there are algorithms that can detect fuzziness across different data elements. So there's a typo in the birth date, the month and the day were reversed, for example. Or there's some standardization issues with the address. One has an apartment number, the other one doesn't, but the algorithms can figure out that those are close enough and probably the same person. And what we see is that typically using those techniques and solving the easy ones, which are the ones where the data happens to match up exactly, you kind of get the answer right about 70% of the time. And then what happens is the remainder, where there's enough commonality on the data that is very likely the same person, but the system can't automatically decide without incurring the risk of making an occasional false positive, which is just not acceptable. You end up with the rest of these records that should theoretically be matched go into some kind of exception process, a manual queue that the data steward department, which consists of 1, 2, 5, 10, or some cases more people, will manually go through and work and try to get the level of quality up to for the idealized goal of 100% accuracy for every patient. So that's the traditional process. And so the challenge with that is that it takes increasingly more effort to get you to the level of accuracy that you want, which is at or near 100%. So you kind of looking at the steps that people take and sort of summarizing that again. With minimal effort, you can do some matching of records across the systems, and if everything lines up correctly, you can link maybe half of the records you should. If you invest in data quality, which is a good thing to do. You improve the rate at which you're capturing accurate information in the front-end registration system or in your membership system. That improves the quality of data, and then you get correspondingly incrementally better results with that. You go out and you deploy kind of the state-of-the-art in matching software that you deploy, and you tune for your data set, which takes time and effort and is costly. You get to that next level. And then finally, when you employ your human data stewards to work the exception cases, you start to get up into the area where you're 80, 90% of the time getting the right answer. And then we see there's some organizations, a handful, who we say have put in heroic efforts, in which case they've got really enterprise consensus on focus on data governance, and they've got policies for entering data and lots of tools at every point of entry, advanced MPI or MDM systems on the background. They do all of these things, and they get towards up to this 90% rate, but it takes a long time and is very costly. So our proposition, which we'll talk through today, is that there's just a better way to do this, and the way that we'll get into for doing that is by bringing kind of big data into the equation. And so Verato's approach is to add in more data, trusted data, that allows you to automate the solutions without having to have completed every one of those sort of evolutionary steps along the way. So here you see a very sophisticated engine, and the point I want to make is that Verato, we have a lot of solutions for identity in healthcare and beyond healthcare. So all are oriented towards improving the quality of identity data, improving the ability for our clients to resolve patient identity or consumer identity across different systems. Some of those solutions, we are the sort of the matching engine for the enterprise. Think of us as the record locator service or the MPI in the sky, since we're cloud-based. So we offer these solutions where we are kind of the full end-to-end identity resolution process for enterprises. Today, this webinar is geared to talk about how we work alongside incumbent technology, so existing MPI systems, existing HIE software, EMR software. And in this case, we're acting as the oil that makes everything work smoother. So we know that lots of organizations over the years have invested heavily in various technologies. They've spent a lot of money in their EMRs, on integration technologies, master patient index technologies. They've put a lot into that, and we know that we have a way to make those things run much better. And so that's the focus of today's conversation. So let's talk briefly about what that is, and then I'll explain, what our approach is like, and come back to some of the more specifics on how these solutions work. So we have three ways that we typically work alongside client technologies that are in place, on-premise MPI software, typically, but also EMRs that have their own, internal matching solutions. So the first thing is this data stewardship concept. So we've got a specific solution where we basically have a automated data steward. So you think of us just like a person who would sit down at your manual resolution queue to work potential duplicate, potential linkage tasks, except instead of a person doing that through a application, basically you call Verato Web Service, and we use the data, external data that we have, reference data that we have, to answer these ambiguous questions on linkages. And we'll talk more about that as we go forward here. And that's a very lightweight way for us to come in and quickly improve the accuracy of your patient data. The other way is that basically we can audit an existing system. So if you have an MPI, you're not sure, or you have an EMR, you're not sure what your true rate of duplicate rate is, how many opportunities you have missed to link records for your patients across systems. If you don't know what the answer to that is, we can use our solutions to first, quantify the problem, tell you how well you're doing, and then we can actually provide answers back. So the false negatives that your existing solution is producing, you can correct those, and you can automatically correct those. And that's another area where we come in, we kind of sit right behind an existing solution, so there's no rip and replace of interfaces and things like that. Another kind of lightweight way to deploy us, but get substantial benefits in terms of the quality of your data that's coming out of your existing systems. And then the last thing is there's some cool scenarios where we actually can help on the front end of the process. So anywhere that data is coming into your ecosystem, we can actually validate the quality of that data, and not just the quality in terms of, or is your SSN, 9 digits long, or is your phone number properly formatted, but actually is that data correct? So I'll get into that, how we do that in a second here, but by improving the quality of data that enters into your system, sort of naturally makes all of your technology processes throughout the enterprise work much better because they're based on a higher level of data quality than you have today. All right, so let's talk a little bit about how that works exactly. So what we offer is we have a solution that's a combination of the new matching technique we call referential matching, and importantly, this database we call Carbon, which is basically a longitudinal demographic history of patients or consumers. So we have created this asset that has a very rich definition of nearly every person, nearly every adult in the U.S., and then we have these referential matching techniques that use that as a source of truth, and it helps us get automated answers to things that it's just not otherwise possible to automate. So the center of this solution is this data. Give you a brief background on what that is. We basically start with credit data, which is fairly robust. It's not perfect, but it's a great start and has great coverage of people across the U.S. And then we incorporate additional data sources that we know are come from different places. So telecommunications data, various government public data, legal data, and we combine all that together, and that's what forms the basis of this longitudinal person record we have. And then we constantly update this data set as well, so it stays current. We specifically go out and find data sources where we know we'll get address changes on a timely basis, and so we're able to keep up with a very current definition of what each person's demographics look like. So if you look inside of there, what you'll see is the same types of attributes that you'd be familiar with from a matching perspective. If you have an MPI or MDM system, you name, address, date of birth, social security number, phone number, those types of things. So the data elements are similar to what you'd have, what you'd see, but the quality of them, the richness of them is much better. So when we compare the data we have in Carbon to the data we typically see from our clients, almost every record we have has all of the data elements, whereas client records, oftentimes some of them are sparsely populated. You don't have an SSN for everyone, or your organization has stopped using that entirely in your collection process. Maybe there's reasons addresses are not complete. You require a zip code, but you don't require the full street line, things like that. So when you look at our data set, it's very complete. And then it's also deep over time. So we have historical attributes built up. So in some cases, up to 30 years of history for name changes and address changes and things like that. So as people move over time, as they show up at different facilities to receive care, as they change health insurance plans over time, their demographics are sort of naturally changing over those time as well. So by having a full history of those demographics, we're able to get much better results when it comes to making matching decisions. So the way that works, again, to kind of contrast with the approaches that you all are probably familiar with, is typically with a pairwise matching approach, an ETL or MPI type approach, what you do is you take the record from system A and records from system B, and you bump them up against each other. As I mentioned before, if you get good alignment of the attributes, you know they're the same. But if there's some discrepancy in the attributes, the addresses come from different dates over time of when you visited that facility, the certain data errors, other things like that. Way too often, the systems will not generate a proper match decision that these two records represent the same person. So with the Verato solution, what we do is we actually take the record from system A and we just match it to our Carbon database. We say which person amongst this unique list of people that consumers, patients that we have in the US, which person owns this record A. And then we do the same thing for record B. And we tie that to the person in reality whose demographics match that. And the demographics can be completely different from A and B, but we've tied them to the same person inside of a set of Carbon, and so we know that they're the same person. And so that's really where the power of the solution comes in, is having this extra data available to make the right decision. So there's a few areas, I mentioned some of these already, where this solution helps particularly. And again, the cases where you happen to have the correct data about a person in both systems, and I shouldn't even say the correct data, where you happen to have the exact same data, those any system will determine those are the same. That's great. It's the cases where there is a discrepancy in the data that are hard ones. And so the places where we really see the biggest impact is if there's sparse data. So if some of your data sources are missing some key attributes from time to time, or if you tend to have anonymous values or sort of nonsense values in fields because you have a requirement to enter a SSN, but people just type in 1, 2, 3, 4, 5, 6, 7, 8, 9. That's another example of sparse data. There's actually no information in there. So as you start to have fewer and fewer attributes in your own data set, then the benefit you get from bringing in this high quality external data set really comes to bear. I talked plenty about the sort of the data errors and the time aspect. The only other thing I'll mention that's interesting and actually very useful is this idea of matching by exclusion. So since we have this Carbon answer key, it's the unique list of people in the U.S. When we try to match a record, we're expecting to find one and only one match for that. And so that's very different than when you're taking just a pool of patients inside of an EMR and you're trying to figure out which ones all match together to the same person. Us expecting to find one and only one match allows us to use some very different things. And those techniques really help when it comes to the trickiest parts of patient matching. So, family relationships. You have husband and wife and they have a similar name, that type of thing. Twins, that type of thing. Having this sort of answer key and the ability to go in and look at the alternate matches allows us to have a much better hit rate, meaning lower false negatives, at the same time as having a much lower risk of causing a false positive, which again is something that's just not tolerable in the healthcare space. So I mentioned this is just kind of going back now that you understand a little bit about how we approach the problem with this Carbon reference data set. I just wanted to walk through those first use cases I mentioned before. So this is a scenario where an existing MPI system answers a chunk of the potential matches correctly, and then it creates this big manual queue that people have to look at. So the way we plug into that is instead of having many people manually working these things, getting through a couple hundred a day, you take your manual queue, you call our web service, which is just available, which is just directly available, and we provide back the answer. Is this each task, is this the same person or not? And you can automatically reflect that inside of your EHR, your MPI. You can basically do a merge. That's very simple, lightweight. It's just a service call and plugs right into your kind of interface architecture. The second one that I mentioned before was this idea of doing an audit on an existing EMR, HIE, MPI system, membership system, where if you have a concept of links already, which you would with an MPI, then basically we can confirm the ones that are right. We can recommend data improvements. So again, we have reference data. We know what the proper demographics are for people in terms of current name, birth date, social security number, things like that. So we can actually flag which data values you have that are correct and which ones are incorrect. There's also the potential to discover false positives. If you have a matching approach that is letting some false positives through, the fact that we are matching each record against our answer key allows us to see those cases where maybe you've linked two records, but they in fact should be linked to two different people in reality because they're twins. And then the biggest thing that we see is this false negative idea. And so it's the many matches that we see in typical systems, even if there's been a lot of effort putting into tuning them, the data inside of those databases is just not robust enough to get the answer right. So when we bring in our data, we inevitably see these false negatives that can be fixed inside of an existing system. And then the last one, this kind of goes to the Verato as the matching engine, the enterprise matching engine solution, is at sort of any point of entry of data into the system, we can be the arbiter of truth for identity. So one is we verify that the person you're entering actually exists in reality. So there's some sort of broad use cases there that we can be used for. We then tell you if you've entered in the right information. So you may be a registration, you go to register the patient. We look them up inside of Carbon and we say, yep, we found that person, we know who they are, but the birth date we have on file is not what you typed in. And the registrar could then look and say, oh, yes, I did, I did fat finger the year and it was 78 instead of 87, something like that. And then the last three bullet points you see on here are where we're actually managing the ID. So this is where we are the record locator service or the lightweight MPI. Every person that comes into your system, we assign a Verato ID to it. I should say every record, we assign a unique Verato ID to it, and allows you to link that with any other records that have come in through other data entry points who also receive the same Verato ID from us. And I said that as sort of a technical implementation way with a Verato ID. We can also be sort of the true record locator service where we're just managing that cross-reference of your own MRNs across systems and giving you that list anytime you think of a sort of PDQ implementation if you're on the HIE or provider side of things. So that's the third way that we commonly interact with MPI systems. And like I said, this third one is, it also gives you a little bit of a picture into how we operate standalone for clients who are sort of greenfields from an identity resolution perspective. So just real quick, just a couple little charts on the actual benefit that this approach has. So we've got a number of interesting use cases, proof points that we did with clients. This one in particular was neat because the nature of the data set from the client was such that these 3.1 million records labeled database A, by the definition of where they came from, what these data meant, every one of them should have been covered by the 44 million records in database B. So it was a really good use case because you knew that you should match every single one. So we were able to do a benchmark against the existing MPI that was in place. And it was a good MPI, and the client had spent a lot of time tuning it. It was just operating against data that was of low enough quality and had enough variances in it that they were limited by the number of correct answers they could get. So when we brought in the Verato data and bumped up against that, we're able to go from this 70% resolution rate to 98%. And so that was a very stark example of what the data and the referential matching techniques could do. The other one here real quick that'll show you, this is a use case for an HIE, and I won't go through all the numbers on this slide, but I wanted to point out this auto steward idea. So the 187,000 exception queue, those are tasks that the existing MPI for this HIE had generated. They were likely the same person, but couldn't be automatically linked with 100% confidence. So these are the things that were going to have to be worked by persons, and it was just going to take too long to get through that list. So we processed that queue, and in a matter of a couple of weeks, we're able to resolve 75% of those exception tasks. So, you know, taking the queue from 187,000 down to 45,000. And then on top of that, we did do this audit that I mentioned before, and that produced an additional set of links that we were able to identify. And in the end, we helped the HIE double the number of connections that they made across participating facilities, which is great. You know, it literally means that when a physician goes and logs into the HIE and tries to get a patient record from one of the patients they're seeing, they're twice as likely to be able to get that record for that patient as they were before we, you know, implemented these this augmentation of the MPI solution. Okay, so so that was sort of the how and what we can do. As far as, you know, ways to get started, basically just a summary of what I mentioned before, which is we've got this data stewardship thing. If you have a task queue and it's sitting there and it's growing and not shrinking, that's something that we can help with pretty easily. If you're just where you're at in terms of quality with an existing MPI or HIE or EMR solution, we can diagnose that very quickly and produce a nice report that not only says how many duplicates or links you have that can be resolved, but also gives you a view into this idea of how correct your data is. You know, so how many times are you, you know, missing social security numbers or have birth dates that might have an issue with them, that type of thing. And then the last piece is this this kind of real-time interactive use of our web service, where we can basically give you an identity decision every time you create a new record. And those could be from different entry points and even across different organizations. So we've got you know, clients who are trying to collaborate provider with a payer, and not through any kind of you know, existing collaboration. Well, if folks just simply call the same Verato service that we offer, you'll get the same identity answer. You don't have to go adopt a whole bunch of common infrastructure, install some you know, MPI software in the middle, but just by the nature that the different participants are using this same standard web service, you can get a consistent answer across different institutions. And so that's another way that that we're seeing clients be interested in using us, you know, across organizational boundaries. So leaving the engine analogy behind a little bit and probably dating myself, there's Bugs Bunny fans out there, you'll recognize Cecil the Turtle. So you've got some existing infrastructure in place. If you do have existing infrastructure in place and you bring Verato into the equation, then, you know, we're not saying you have to throw that whole thing out. We're just giving it a turbo boost, very quickly and easily making your solution a lot better than it is today. And like I said, if you're the type of client who hasn't invested in the solution and is more of a greenfield and you have new use cases or are trying to integrate with new partners, then we also have solutions to help you do that kind of from the ground up as a cloud-based record locator service.
Thanks, Joaquin. That pretty much sums up the presentation section. We have some time for 3 or 4 questions. So if you have questions, please chat them in now. If we don't get to them, we can always address them offline. And before I get to the Q&A, I just wanted to make an announcement about our next webinar in this summer series. We're really excited to have Lorraine Fernandez join us next month. She's well recognized in the industry for her thought leadership in healthcare information governance and patient identity integrity. As you know, today's session was a little more tactical about how you can improve your EMPI program or sort of start fresh with a cloud-based record locator service. But Lorraine is going to take a step back and talk more strategically about the bigger picture as to why getting patient identity right is, in the first place, is becoming increasingly important today. So I just wanted to make that announcement. And with that, we will go ahead and ask some questions for you, Joaquin. One of the first questions is, when you give back those matching auto data stewardship answers, do you just give back a yes or a no?
Yeah, that's a great question. So we do give back a yes or a no. But one of the unique things that we do is we can actually provide the substantiating information for that. So, when we get an answer that a traditional MPI system could not get, the reason is because we've got some additional data points that gave us the ability to answer that question confidently. So maybe it's the address history. One record had a current address and one record had the old address. So when we reply, we say, yes, they're the same, and then we actually provide that indication that these are the addresses. We had both these addresses on file for this person, and we give you the metadata to see that. And that stands for other types of reasons too. So, we had the name history, for example, things like that. And so the, HIM folks especially have been, received that very well, as being able to dive in and look at the evidence, even log that evidence, record that for audit purposes. So, when an automated decision is made, it can be logged as, the user was Verato, and you can also record this supporting evidence to have as an audit trail in the future.
Thanks. I think that might have answered this question, but just in case, a quick follow-up. Is Carbon kind of a black box that matches, or can the user see the data for the match?
Yeah, I think that is a similar question. So, we're simple, like a black box, in terms of you call our web service and you get the answer, but the data that we return does include that additional information, so you can understand what's happening inside of the box. So it's more of a white box, because we do show you the evidence for how the decision is being made.
Okay, and we have another question about Carbon, about the data in Carbon. Do you have household data inside of Carbon?
Yeah, good. Yeah, another good question. We have relationship information, which covers a few categories, one of which is household. So some of that information we kind of get explicitly from the reference data we have, and then other data we derive that. So it turns out that that's, I didn't really go into what the techniques on what our referential matching techniques are, but a lot of that has to do with not just looking at the system record A you're matching and does it match to that one person in Carbon, but we actually look at the relationships that record has with other people. And so when we're trying to sort out these difficult questions, which are often family related questions or household questions, we look at the other members of that family, the other relationships there, and use that to rule out the possibility that a record could be someone else in the family. So we do have that information and use it as part of our referential matching process.
Okay, another question is, can Verato work with any EMPI or EHR vendor, or do you have a list of partners that you work with?
Yeah, so the answer to that is both. We're definitely generic service, and we can integrate with a variety of EMRs, HIEs, either directly or through integration engines. So we can definitely play with those. We have specific experience with a handful of them, and so depending what systems you're on, we would definitely like to just find out what you're on and talk to you. It's very likely we can tell you about cases where we've implemented against the same EMR, and in that case we have some best, or MPI system, and then we have some best practices, knowledge of how to do that in as simple a way as possible.
All right, thanks. I think we're coming up on the 45-minute mark. There are still a couple of outstanding questions, and we'll get in touch with you all regarding those. So don't worry about that. Thank you so much, Joaquin. Thank you, everyone. This was a great session, and have a nice day. Bye.
Great. Thanks, everyone.